All right, my students had to put up with me doing some strange things just a second ago, so we're redoing the video. We're doing a chair problem, and in this chair problem, you're not told if it's cis or trans, you have to figure it out first. And your second chair will be of this format, where you're given stereo center information and not cis or trans information. So what you have to do ahead of time is some advanced work. And I'm going to do it like this. Rough work. And that rough work's no good because I have the wrong group up there. That was where our whole situation fell apart earlier. Yeah. The group on 1 is called undechial. That's easy to draw. What? Whoa, that's a big redaction wide thing. 1, 2, 4, 6, 8, 10, 11. It's a stereo center. Carbon 1's a stereo center, right? And a stereo center has to have 4 different substituents, right? What's the 4th substituent? Hydrogen. Thank you very much. Carbon 3 has now read this carefully. Draw the ethyl first, because that's what's attached to cyclohexane. Draw the ethyl first. Okay, the end of a group is what you draw first. Put the bromo on the first carbon of the group. Remember, carbon 1 in the group is the carbon attached to the chain. In this case, the chain is cyclohexane. So carbon 1 has a bromo. And unlike our botched video, I'm not going to worry about the stereo center in this group until it's worth points up in the box. I'll do it then. But I didn't finish my 4th substituent on carbon 3. What's that? Hydrogen. Thank you. And now we just got to make sure stereo center 1 is R, and also stereo center 3 is R. And you remember how you do that? You do your priorities: 4 for a hydrogen, 3 for a carbon that doesn't get a branched carbon at all, 1 for a carbon that goes to a branched carbon in the next step away. That carbon has 2 bonds to carbon. You can't say the same thing about the second carbon away from the stereo center here. It has only 1 bond to carbon. So that makes this. And I connect 1, 2, and 3, and it is currently already clockwise. That means if the number 4 group is on a dash, then this thing will be R. If the number 4 group was on a wedge, this thing would be S. Which of those 2 do I want? The question says which one I want, right? I want R. Put the 4 on a dash. And stay outside the rings for the wedges and dashes, people. When we go to chairs, we're not doing wedges and dashes. So just a reminder, reminder, up equals wedge. This will be your last reminder. Down equals dash. Because when you go to chairs, it's all about ups and downs. It's not about wedges and dashes anymore. Please don't put wedges and dashes on chairs. Okay, what about stereo center 3? It also has to be R. Current situation, carbon with a bromo is going to beat, well, everything beats H. Carbon that goes to a branched carbon, carbon that doesn't go to a branched carbon. This thing's currently, if you connect 1, 2, and 3 and the number 4 group's on a dash, it's S. I don't want it to be S. What's the fix? The fix is easy, people. Don't put the 4 on a dash, put it on a wedge. This is how we should approach every stereo center every time. Do it without the wedge dash. Connect your 1, 2, 3. If it gives you the desired result, put the 4 on a dash. If it gives you the opposite of the desired result, put the 4 on a wedge. That covers every scenario ever. So no trouble drawing stereo centers for anything, I hope. but you still need practice with stereo centers because they take a long time to learn the 1, 2, 3, 4s and get practice at them. All right, we are now ready to start getting some points. We did all the hard work here. Chair, angles, parallel lines, angles, parallel lines from the inside. Carbon 1, put these two bonds on first, 1 and 3. What was special about those two bonds that I just drew in red? They're the ones you draw first. They're a special kind of bond. It has a name. I need to know the name. Axials first, and it follows the carbon angle. Angle up, axial up. Angle up, axial up. Equatorial, if the axial was straight up, equatorial slightly down and parallel to this and this. I'm going to get rid of those parallels. Z. You had the visual of what the parallels were. It's gone. And similarly up top here, that is parallel to not the adjacent carbon-carbon, but the adjacent-adjacent and the adjacent-adjacent. I'm going to disappear those. There you go. We're well on our way. The undecual, is it up or down? Right here. Up. Which of these two is up? It's pretty clear. What color? The red. Put your undecual up there. 1, 2, 4, 6, 8, 10, 11. Don't forget H down. Yeah, dash is down. Look, dash is down. Now, in this picture down here, which of the groups is up? The H or the bromoethyl? H. Put the H up. And the bromoethyl here. And now I'll do the stereo center on that. Remember, the bromoethyl has a substituent. I drew the ethyl first because I'm supposed to. And the bromo on number 1 of the group, which is the one attached to the chain. And there's a 4th substituent on this carbon. I know I said I was only going to ask it 2 times, but apparently I'm asking it a 3rd time. What is the 4th substituent here? H. I don't want you to get it wrong. Does the number 4 substituent always have to be an H? No, you can have 4 different groups without an H there, right? It's quite common. And now do your normal stuff. And this is not a chair depiction here. This is a group. So I do need wedge dash on this one. And it goes number-wise in green. Not green, maybe blue. 1 for bromo, 2 for a branched carbon, 3 for a not branched carbon, 4 for an H. It currently is R, and I need it to be S. Look, in the name in the group, it has to be an S stereo center. So what's our fix? 1, 2, 3 is clockwise. Oh, don't put the 4 on a dash. Put it on a wedge. And pick an adjacent bond for the dash. The bromo's adjacent. There, you got 5 out of 5 there. Next chair is a lot easier. All the hard work's early in this question. And don't pick carbon 1 to be the top right. When you do a chair rotation, all the carbon angles that used to point up have to point down now. Axials first, down and down. Equatorial, slightly up, slightly up. That's not parallel with the one I wanted. There. Still a little shallow. Yeah. I want it to be parallel. That's better. It's more like that and that. Can you do it again? Indeed. Okay. Hey, which of these two is up? The blue, right? The up has to be the undecual. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Verify. 1, 3, 5, 7, 9, 11. And the H down. And the group down on this one, the H up. And the group looks like this. If you're careful and you draw it like the one before, with the carbon angle similar, then you're pretty sure that's still going to be F. Now we got 10 points. And the labels, come on, those are easy points. The group on carbon 1 in chair number 1, axial or equatorial? Ax. And they're the short forms. AX is the short form you're allowed to use. And what about the one on carbon number, I don't know why that's a 2 there, there should be a 3. Do you know, not know. 3, 2. The group on 3 is down. And what kind of bond is it? Is it axial? Equatorial. Purple. When you go for a chair in chair sigma rotation, axial changes to, what's this? Equatorial. And equatorial changes to axial. And just for review, a bond that was up before must still be up, and a bond that was down before must still be down. Okay? All right. Try to tidy up some stuff a little. There we go. Very happy. And now the magic. Why am I circling this guy here? And my answer is going to be in the explainer box. I need the B word in the box, and I need that funny interaction that's not a good thing. Like I want to avoid one. And so in chair 1, what's the B word? The bulkier, I take bulkier, bulkier bromoethyl group. Why is it bulkier? Ladies and gentlemen, bromo is not a small atom, is it? It's a mass of 80. It's branched right off the first carbon, and there's a methyl branch too. So treat it just like a branched group, and this thing doesn't have any branches at all, right? So the chair number 1, in chair number 1, comma, the bulkier bromoethyl avoids what negative interaction? It's 2 points. 1,3 diaxial repulsion. And the reason why it avoids it's quite easy. It's not axial. It's equatorial. That's why I picked it. There you go. Good video. There's other videos just like this for the stereo center version of the question. I'm sure you'll be able to find them.